Nikah kau ini lah di Nisartia. Good morning, Sinuri. Atau di mana ilah? Hari ini Kalara, Manindu, Lihini, Wasilima, ada Pino belum. Tak cetak kelari wanita itu. Sama ada tamla atau tamu harusnya itu. Makaranti me අම්මලගාත්තල මාසෙකට විතර රැස් කරගත්ත ආහාර ද්‍රව්‍ය සමහර සතියකින් ඉවර කරනවා කියලා. බලන්න ඕන බර බලලා එහෙම ආයෙ සතියකින් බලන්න මොකද වෙන්නේ කියලා. Asyik. Kita ini dia jauh namanya saya sama ini. අපි පටන් ගමු නමයි නේද? අනිත් එන දීලා අයගොල්ලෝ නමයි ඔයගොල්ලෝ හැමෝම සුවයෙන් ඉන්නවා කියලා බලාපොරොත්තු වෙනවා. So we can start our lesson today. We were doing tangents. Tangents to a circle. Last day, finally we did the tangential distance from a point to a circle, right? Tangential distance from a point to a circle. You are given a point P x naught y naught. P x naught y naught and the circle is equals x square plus y square plus 2dx plus 2fy plus equals 0. You are given this point and circle. The point is outside the circle, so you can find the tangential distance to the circle from the point, say PQ, with the point of contact, then the distance D, say PQ distance, if it's D, we said it's given by root of, it's easy to remember, you just substitute this point in the circle. So that will give x naught squared plus y naught squared, then we have substitute this point in this circle, plus 2dx plus 2fy plus equals 0 and not equals 0 plus c, and you take the square root of that. So that gives the tangential distance from this point to this circle, right? And then using this, we explain how to find the position of this point relative to the circle. So that's the thing we discussed last day. If this part, you apply this point to the circle, so you will get x naught squared plus y naught squared plus 2x naught plus 2fy naught plus c, right? If this part is greater than 0, you apply the point in the equation of the circle, you get a positive value. That means the point stays outside the circle, outside, externally. If you get equals 0, that's something we knew from the beginning. If equals 0, the point comes onto the circle, right? On the circle, equal means on the circle, on the circumference of the circle. If this value is less than 0 means the point falls inside the circle. Less than 0 means inside the circle, right? So that's what we did last, and I gave you one question also, so we can discuss rather two questions, I think, for homework examples, so we can discuss them today. First question is this: you also find the position of the point P minus 1 minus 2. This is the point P minus 1 minus 2 with reference to the circle s equals x squared plus y squared plus minus rather 2x minus 4y minus 4 equals 0. This is the circle, and this is the point. So you have to find the position of this point with reference to the circle. It's easy to explain as we said here. You just apply the point in the line, right? point in the line. If you want, you can explain it like this. This is the equation: x square plus y square minus 2x minus 4y minus 4. In this equation, we apply the point minus 1 minus 2. So that will give 1 plus 4 plus 2 plus 8 minus 4. Definitely positive. Definitely positive. So our conclusion, the point stays, it's positive, greater than 0. Our conclusion, the point stays outside the circle, right? It stays outside the circle. Therefore, P lies outside the circle. So this is the answer for the first part, first question. Then I gave another about two circles. Okay, Anagi, let me just connected. Who else? Amasha. Okay, good morning to you everybody. Anita සුදාටියක් කලින් නැගිටින්න ඕනේ. නැත්නම් අම්මලා අත්තලාට කියන වතුර බල්දියක් ගන්න හිටවන්න කියලා. උදේ ආය වෙනකොට. Kemindi. And the second question I gave is this. I gave two circles which are named S1 and S2. Question number 2. Circle S1 is x squared. No, I gave maybe 3 questions. Second question is to show this area, x squared plus y squared minus 4x minus 2x minus 4y minus 4 is less than or equal to 0. You are asked to show this area in the Cartesian plane. To show the area, we need to draw the circle. If all the points satisfying, you are asked to show all the points satisfying this relationship. So this is less than or equal to 0. Less than 0 means the points inside the circle equal 0. That means including the boundary also, right? So the points satisfying this inequality are the points inside and on the boundary of the particular circle. We draw the circle first. The circle has center 1 and 2. The center 1 and 2, I'm going to draw it. Center 1 and 2. 1 and 2. P is the center. Center 1 and 2. What is the radius? Radius is 1 square plus 2 square. 5 plus 4. 9. Root of 9. So it is 3. Radius is 3. So I am going to draw the circle of which center is 1 and 2. And the radius is 3. Radius is 3. So this length is root of 5. Root of 1 square plus 2 square. Root of 5. The radius 3 means it goes outside, right? So the origin comes into the circle. So it's a bigger circle than this. Like that. So the area satisfying this relationship. The less than 0 means all the points inside the circle, you have equal to 0, that means including the boundary, right? So this is the area. This is what we are region. With the region you are asked to show in the Cartesian plane with the region, and that's the answer. Including the boundary, so we draw the boundary completely. If equal is not there, that means not including the boundary. In that case, we would show it by the dot line. The dot line, discontinuous line. But here, including the boundary, therefore we show it with the complete line. The circle, boundary of the circumference of the circle. Radius is 3, we have to show that also. Radius is 3. Now only the answer is complete. Okay, everybody, can we go to the next? Go to the third example. In the third question, you are given two circles. The third question, you are given two circles, which are example 3. Two circles are S1 equals x squared plus y squared minus 4x minus 6y minus 3 equals 0, and S2 is x squared plus 2y squared x squared plus y squared minus 2x minus 2y minus 7 equals 0. Right? These are the two circles given, and the task is first to show that the center of S1 falls inside S2, circle S2, and vice versa. Center of S2 falls inside the circle S1, right? So we have to show that. We first find later on you will need the radio also. We will find center and radius of this, and center and radius of this. Of S1, center, say P is identical to 2 and 3. Radius R1, yeah, say R1 is equal to root of 2 squared 4 plus 3 squared 9 plus the 3 plus 3, right? So that will be root of 16 will be equal to 4. Radius is 4, right? Then we go to the second circle of S2. Center is say Q. Center has coordinates 1 and 1. 1 and 1, and the radius R2 equals root of 1 squared plus 1 squared plus 1 squared plus 7. So that will be equal to 3. Okay, now we have all the information about the two circles. Right? Kita mau berapa bocah karena margane. So the radius is 3. And first you have to show that the center of P lies inside S2. It's easy. You just substitute this point in the equation and it has to be then less than 0, right? You will substitute this point in S2. In S2, let's substitute 0.23. So you get 4 plus 9. 4 plus 9 minus 4 minus 6 minus 7. So it is less than 0. Less than 0. Therefore, P lies inside S2. P lies inside S2. Then similarly, we have shown that the center of S2, that is Q, it was inside S1. So the same way, we will apply this point center in the equation of S1. In the equation of S1, let's apply the point 1, 1. So that will give 1 square plus 1 squared, 1 plus 1, minus 4 minus 6, and minus 3. Definitely less than 0. So conclusion, therefore, Q lies inside S1. Q lies inside S1. Right? So answer for the first part. And thereafter again you have to show some region in the Cartesian plane. Before that, if you have to take down something, you can do it now. Thereafter we have to draw the Cartesian plane to circles and show the region. Okay, and the next part, you are asked to show the region in Cartesian plane for which this one is x square plus y square minus 4x minus 6x minus 3 is greater than or equal to 0, and at the same time x square plus y square minus 2x minus 2y minus 7 is less than or equal to 0, right? Now, by now you know that to show this area, this region, we have to draw the two circles, S1 and S2. This part is, this means the region outside the circle S1. This is the region inside the circle S1, including the area, here also including the boundary, here also including the boundary, right? So we have to draw the two circles and show the region outside and including the boundary of this circle, at the same time inside and including the boundary of this circle. So we'll draw the two circles in the Cartesian plane first. S1 has a center 2, 3 and the radius 4. Center 2, 3. It is somewhere here. 2, 3. The center is 2, 3. Center P is 2, 3. And the radius is 4. Radius is 4. It's somewhat a bigger circle. We come to 7. In this side, number 4. Radius is 4. Radius is 4. This is circle S1. Next, we'll go S2, of which the center is 1, 1. 1, 1. One and one. Center Q is 1, 1 and 1. And the radius is 3. Radius is 3. It's a smaller circle compared to this. But 3 will the part will be outside this circle. Over here. So this is the center of the second circle, and the radius is 3. This circle is 2. We want to show the area. Don't we need to find the intersecting points? No, you don't need. We just show the area, the region that we need. No need of finding them. That much of details are not expected to show, right? This is enough. You don't need to find these points of intersection. That's too much of detail. So we want to find the region outside S1, including the boundary, and at the same time inside S2, the small circle inside S2, including its boundary, right? Including its boundary outside the first circle and inside the second circle. So you see that it is this region. This is what we need. That's the answer. It's like a crescent on the power. Chandra, a crescent. So this is the answer. This is sufficient for your answer, right? Very rarely, very rarely you need to find points of intersection of two circles, right? Even a circle and a straight line, not we use that thing. That means solving equations and finding points of intersection. Very rarely we use it. Why don't we shape the union of those two? Not the union. Read the question again. Kevin. The question given this and union is for, and means the common region. Satisfying that and this. Both have to be true. If you need the union, this has to be not and. Then what should be? You will show the union if it is what? Union means should be connected by O. Yes, correct. O. Yes. But here in this question, it is and. And right? Satisfying both the conditions. Okay. Another question. The circumference of S2 of the shaded part should be in dotted line, right? No. Because in the question, this one is greater than or equal to 0. That's why I told you it's including the boundary. Equal to 0 is there. Here also less than or equal to 0, including the boundary. So in the region we are showing, both the boundaries Both the boundaries should be there. Both the boundaries should be included because equal 0 is there also. Only less than 0 in the, is that how I gave last day? Yeah, the other says equal to 0 is also there. Please correct the question. One more again. See, please correct the question. Yeah, equal to 0 is also there. Maybe you have copied it incorrectly. Okay. Okay, now I think it's clear now. Never mind. So can we go to the next topic? Next theorem, another important theorem. It's a mistake, lah, right? ඒකනේ මම මේ night time පාවිච්චි කරලා night time data නම් ඇත්තේ හැමෝගෙම නේද? අද මාසෙ මුල නිසා හැමෝටම මම හිතන්නේ day time එකක් ලැබිලා ඇති. night time කියුණාට night time පන්ති කරන්න බෑනේ. ඔයගේ මගේ ඇරෙන්නේ වගේ එතකොට night time data දෙන්නේ මම හිතන්නේ මේ වවුලන්ට බබමුණුන්ට කලරැටුන්ට වගේනේ. අපිට combine match night time කරන්න බෑනේ ඒ නිසා මේ කොහොම හරි මේ data පන්ති කරගෙන යමු. night time කරන් ගොතම මොනවා වරද්ද ගන්න ඉන්නේ. Right, we can go to the next theorem. Again, an important theorem. The previous theorem also, the distance, tangential distance from a point to a circle. That's also some important theorem. They frequently ask questions from that. And this one, the next, is even important. Very frequently they ask questions from the next theorem. It is theorem for the chord of contact. The name is equation of chord of contact. Name of the theorem, equation of chord of contacts. So what is this chord of contacts? You are given a circle. You are given a circle, right? And a point outside the circle, say some point P outside the circle. Last day we have seen that you can construct two tangents from this external point to the circle, right? So let's draw them. Two tangents. These are the tangents. To the circle from P. Tangents to the circle from P, right? And then right, so suppose that the two tangents meet the circle at points P and Q, or the points of contact. Points of contact of these two tangents with the circle. Say they are P and Q. These are the 2 points of contact of two tangents. You join this line, draw a line segment, straight line segment, joining these 2 points, and it is this line segment or the chord you call the chord of contact. So this circle, chord of contact to this circle from this point, right? So this is what you call the chord of contact from the point P to the circle S. So that is the chord of contact which joins the 2 points of contact of these tangents with the circle, right? But now the theorem is to find equation of this chord of contact once you are given equation of the circle and coordinates of the point P. You know coordinates of point P. You know equation of the circle. Now how to find the equation of this chord of contact? The theorem is for that we can write the theorem. Point C can be used for no. I'm sorry. We'll some other name. Say R. Let this point be R. Okay. This QR. We have already used the point P. Sorry, it's my mistake. Let there be Q and R points of contact. So this QR is the chord of contact. You are correct. Okay. The theorem says if your circle is the general one, x square plus y square plus 2bx plus 2x plus equals 0, then say the point is x naught y naught, and y naught. The equation of chord of contact from the point P x naught y naught. So the point is x naught y naught to the circle. Don't mistake this. We say from the point, right? From the point P to the circle, but this chord of contact does not pass the point P, right? It never meets the point P. But we say the chord of contact to the circle from the point P, or with respect to the point P. To the circle, say the circle is general one, x square plus y square plus 2bx plus 2fy plus equals 0. This is circle. This is the point P outside the circle. Then the equation of this chord of contact is given by this x naught x naught plus y naught plus b times x plus x naught plus f times y plus y naught plus c equals 0. So this gives x naught plus y naught plus b times x plus x naught plus x times y plus y naught plus equals 0. This gives the equation of chord of contact. Now, clear that keep the next right there. You think I wrote it by mistake? Because the same thing you met last day also. The same equation we have seen last day. X naught plus y naught plus b times x plus x naught plus f times y plus y naught plus c equals 0. Yeah, tangent. Oh, sorry. Tangent yes. We wrote the same thing last day, but not for the chord of contact. Last day we wrote it for the tangent. So what is the difference here? The same equation, we wrote the same equation, but last day we wrote the same equation for the tangent. For the tangent, then this point should be on the circle. X naught y naught should be here, right? If the point P x naught y naught is right here on the circle, the same equation gives you this tangent, right? If the point P is outside the circle, x naught y naught, the same equation gives you the chord of contact. It has to be there. It is the same equation, yes, right? So we will prove it. Okay, we are going to prove. Don't keep any doubt. Right. First, I think you can take it down. Then we'll go to the proof. It's a very beautiful proof in mathematics. Some logical proof. Balam proof second form. It's a real in the book. For the Karin in the Sinit in the Maharo the Bantiamo the Manel. Ah, yeah. Zenith is there. Okay. So as Kavi. So can I go to the proof? Okay. Okay. So with the circle, with the point P outside the circle. These are the two tangents from P to the circle. Let them meet the circle at from the point of contact be Q and R, Q and R, and this is the point of contact. Right? I told you that it's going to be some interesting proof here, interesting logic, right? The way that we do the proof. We start by, so we are not going to derive the thing that we need, that expression, we are not going to derive it from some computation and get to that at last. Instead, we start by writing that expression that we wrote in the theorem, right? We start by writing that formula. Consider the formula x naught plus y naught plus b times x plus x naught plus x times y plus y naught plus c equals 0. Right? Our proof is of two steps. Two steps. First, we will prove that. This represents the straight line under any circumstance. This represents the straight line, right? So you can easily prove that this is a straight line, First we'll show that this is a straight line, then we'll show that that straight line always passes this point Q, and it always passes the point R as well. If it's a straight line and it passes the point Q and point R, then it has to be, this has to be the equation of the chord of tangent QR. So that's our plan. First show that this represents a straight line, then we will show that that straight line passes that point Q, the point of contact, then we will show that the same way it passes the point R also. So then finally we can conclude easily. Then this represents the chord of contact. Okay. The first step to show that this is a straight line, it's very easy. You can see that it's an equation, a linear equation of x and y, g, f, c, x naught, y naught, g, f, c. All these are constants. Therefore, this is surely a linear equation of x and y. We know that the linear equation of x and y always represents a straight line, right? This is a linear equation. X and y. Therefore, one represents a straight line. One represents a straight line, right? Now we can speak about that straight line. So I told you that it's an interesting logic that we are going to apply here. Now we said that the tangents that we draw from the point P to the circle S meet the circle at the points Q and R. So the points of contact are Q and R. Let's take some coordinates for them. Assume some coordinates for the points Q and R. Let this be x1, y1. Let this be x2, y2. So let qr1, qx1, y1 and rx2, y2 be the points of contact of two tangents with the circle. Okay. Now conversely, so if Q1, Qx1, y1 is the point of contact of this tangent with the circle, right? Now we have like a point in the boundary of the circle. So the circle is circle has the equation x square plus y square plus 2bx plus 2xy plus b equals 0, right? So we have a point in the circle. Q is a point in the circle, so the components of the circle. So we can write down, like on the other hand, we can write down equation of this tangent. Equation of this tangent to the circle through the point Q, right? Through the point Q. What is it? The equation of the tangent to the circle through Q. Rho Q x1 y1. We have coordinates. Of the point x1 y1, and we have equation of the circle. Last time we learned how to write down this tangent, equation of the tangent. So it's given by x1. x1 y1 is the point. x1 plus y1 plus b times x plus x1 plus y times d times plus x times y plus y1 plus c plus 0, right? Plus c plus 0. So this is the equation of the tangent, right? And we know for sure that this tangent passes the point P, because it is the tangent we drew from the point to the circle, right? Now we wrote the equation of this tangent from the point Q to the circle, so it definitely passes the point P, right? So this should pass the point P. This passes, definitely it passes x0 y0. Therefore, we can apply x0 y0 in this equation and it should be satisfied. So x y replaced by x0 y0. Therefore, x0 x1 plus y0 y1 g times x0 plus x1 plus x times y0 plus y1 plus c equals 0, right? Because this tangent conversely passes the point P, we can apply coordinates of P x0 y0 in this, so that's what you get. Now look at this carefully. Look at this carefully, everybody. And what is the use that we can take from this? What does this say? Something very important. Yan ba makadeging ng projenin? Use of this. Let's go back to this equation. This one we have started, and at the beginning we said this is a straight line. We have proven that it's a straight line. And what happens if we apply the point Q x1 y1, this point Q x1 y1 in this straight line? What is it? Applying the point Q x1 y1 in this line, this straight line, if you notice that we get the same equation as to got here, and we know that it is equal to 0. The chord passes the point Q, not the chord. Yeah, this straight line, whatever it is, this straight line passes the point Q. Yeah, that's what we take. That sense is correct. So now we can conclude that this straight line, whatever it is, it should pass the point Q. Was that everybody? Therefore, the straight line 1. Therefore, the straight line in 1. In 1 passes Q. So we have proven that this straight line passes the point Q. So no need of wasting our time. We can similarly say, this straight line passes the point R as well. No need of writing all these stuff again. You just say, similarly, this straight line passes R2, right? Similarly, we can show it passes R as well, right? So first we have shown that this is a straight line, this is a straight line. Then we say that straight line passes the point Q, and finally we say that straight line passes the point R as well. Then what should be this? This is a straight line which passes Q and which passes R as well. Then this has to be the equation of that code product contact QR. So hence the proof. We'll write one more sentence here. So this is the proof. I think everybody, you got the idea. The logic behind the proof. Is that clear, everybody? Okay, you can take it down. You can take it down the proof, then we can go to examples. How can we say at the end that is the equation of the code of contact? The thing is this: if it's a straight line, if it passes Q, if it passes R, then definitely it should be this straight line. QR, what we call the code of contact. If this represents the straight line, it's a straight line. If it passes this point Q and if it passes point R, then it has to be the equation of QR. And QR is the code of contact. It's a simple argument. Ms. Asya? Okay, take it out from my identity. It is not equal. What do you mean? It is not equal. We get the answer in the same way. Not the answer. I can they're asking about this. So we can again write down equation of the tangent through the point R and say that it should pass the point PS naught, Y naught. So we will get some expression like this, taking the point R also. Similarly, you can say it this straight line passes are as well. You don't need to write it again, all the stuff again. Hmm? It's the same way. The same way you can uh, prove that statement passes are as well. Usually we don't write the same thing twice in mathematics. Hmm? It's only like wasting our time. Repeating. Only thing you replace q by q by r here. The rest will be very much same. Instead of x1 y1, you write x2 y2. Argument is the same. Yeah, sometimes they ask these proofs. Yeah. As I told, this is the theorem that they have asked mostly in the proof and in questions also to use in your answers. This is like a very important tool in circle. So you can easily write down this proof. No? Then pick up ugly proofs, but you can't rule out that. There's a chance. Probability that they are proof also you have to get ready. You should remember the proofs. Yeah, and yeah. Running with the straight line in one passes q and r but by one pq pr නෑ අරත ගන්න එපා මේ බලන්න පොඩි ආගමන්ට් එකක් අපි දැන්නේ අපි q වලින් හරියට ටැන්ජන්ට් එක ලියුවා we got equation of the tangent through the point q right it is this it is x1 plus y1 plus b times x plus x1 plus x times y plus y1 plus equals 0. This is the equation of the tangent. This tangent from the point Q to the circle. That's something we have proven last year. There's not any doubt about this, right? Then we said, not this, not this. This is the equation of the product tangent. It's x naught y naught. This is the product tangent. When you have x1 y1 here, that represents this tangent. If you have x2 y2 here, that will represent this tangent. But what we are saying here, it is this x0 y0. X0 y0 is a point outside the circle. Something outside the circle. It depends upon where the point is. If this point is here, the same thing will represent the tangent. If it is outside the circle, it will represent the product concept. Are you ready? එකම equation එක නෙමෙයි. x0 y0 මෙතන තිබුණා නම් it's the tangent. ඒක එළිය තියෙනවා නම් it's the product concept. Apparently the same equation, but two ideas. This is the product concept. We said this is the product concept, not this one. It takes 1 by 1. It is a tangent. Okay. අද කො මේ සිරිමාව ළමයි කො අංජනා නැද්ද? විනුලි නැද්ද? අද වෙන ලින්ක් එකකට ගිහලා මොනවා හරි බලනවද දන්නේ නැහැ. ෆිල්ම් එකක් යනවා. Vinuli, Vinuli is there. Okay, nice to see you. Polini, Pena Madi. Where's the other part? Sirimao, the other part. Raman idiya diyangena neda kawuru yarewana unde නැත්තම් වෙන ලින්ක් එකකට ගිහිල්ලා වෙන මොනවා හරි බලන්න. Finished, everybody? Yes. Finished? Yes, 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 yes. Okay, thank you. So we can go to examples. Okay, we'll do few examples. निकाह का रूप से पार्ट कर लिया बैठना नाम है यहाँ पर बोलता बदला निकाह मैंने लगाकर बदला दिया करना ओके जाना बुद्धिस्ट Yeah, your answer finally. What is it? 3x minus 5y plus 17 equals 0. Correct. Correct, Kanil. Yeah. That's what I also got. So can we go to the next example? Example 2. The code of context from the variable point P to the circle x equals x squared plus y squared plus 2x plus 4y plus 1 equals 0. Always passes q2 minus 3. Show that the locus of P is the straight line 3x minus y minus 3 equals 0. Okay, you can try this. Yeah, how to start it? How do we start it? Yeah. Take some point. Take the point P with some coordinates. Shall I write alpha beta? Hmm? Net meter में alpha beta भागन value ला ने? Come on, A B O something x1 y1. Better we like Andan over what I can get Kamal. Okay, anyway, the idea is correct. Answer say that the idea is correct. PB identical to some alpha beta. Hari correct na yes, your answer is correct. So you get like taking x out. Remember that alpha beta are some parameter alpha plus 1 taking y out, then give y out beta plus 2 and then plus alpha plus 2 beta plus 1 equals 0. This is the chord of context, taking the point P as alpha beta. This is what we get for the chord of context. And now we are given that it always passes this point Q. So this equation will satisfy the point Q. You get some relationship of alpha and beta like this. The relationship of alpha and beta like this. Simplifying it is 2 alpha plus alpha, 3 alpha minus 3 beta plus 2 beta minus beta plus 2 minus 6 minus 4 is minus 5. 2 minus 6. Yeah. We are going to get the answer. -3 equals 0. And the last step, Last step is to, we have the relationship of alpha and beta. The last step is to replace alpha beta by xy. Yes, yes, yes. Replace alpha beta in xy to convert it into the equation of the straight line. Yes, yes, the answers are correct. So replacing alpha beta by xy, we get finally we get 3x minus y minus 3 equals 0. This is the equation of the path of P. Okay, we can go to another question. Question number 3. From the variable point P to the circle, square plus some square. Okay, this is the question number 3. Get right. Did you come up with this as to start? Yes. Then what is the next condition? The requirement is this tangent, this chord of tangents, whatever the straight line, this straight line should touch this, be in contact with this circle. In contact with the circle. How to use that? The circle is in the form x square plus y square plus r square, right? And this straight line we can write in the form it becomes a tangent to S2, but what is the use of taking so? On S2. No. You remember what we discussed the very first day, the requirement to be a tangent or the circle to be in contact with the straight line. The requirement here, the circle is in the form x square plus y square plus r square. Yeah. Yes, maybe it's correct. Yes, B equals R. That is also correct. But we can use the expression, but let me say, yes, c square equals r square times 1 plus n square. We can use that expression because this straight line you can write in the form y equals mx plus c. And the requirement this straight line to touch the circle is the very first lesson we have seen that c square equals r square plus r square into 1 plus n square. This is the requirement. But for that, to use that, shall we write this equation in this form, y equals mx plus c form? Better we take it in that form, so that will give y equals minus alpha over beta x plus 16 over beta. This is your m and this is your c. This is m and this is c. Yes, Misaka, but you can use this the formula that we have, right? Hari, Karan, man, hello, Tregan. You can finish it. First, you write this straight line in the form y equals mx plus c to identify m and c. Circle is already in the form x square plus y square equals r square. You can now you have everything in the everything that you need to use that expression. C square equals r square into 1 plus n square. Karan balan nama? Igre Karan. Finished. Okay. So you reach to this alpha star plus beta star minus 1664 equals 0. As the final step, we replace to convert this into the equation of the circle. We replace alpha beta by xy, and you get finally x squared plus y squared minus 64 equals 0. That's the path of the point P, variable point P. Finished, everybody? Finished? Yes. Okay. If you have finished, we can go to the next theorem. But before that, I want to ask you if you have any question from the homework. I gave some exercise from the textbook. Do you have any question to discuss? ఏమన్నా పొడి పొడి ప్రశ్న ఒకటి మన కాల్ కట్టేది ఆన్సర్. We want to discuss in detail to work on the board. Any question from homework, the book exercise? I don't understand what they are asking in the 19th question. 19th. Page 19. Maybe the page number is 192. Yes, I'm there. Okay, 192. You are asked to find. You are asked to find again the path of a point, path of a variable point. The requirement is You are given two circles, this one equals 0 and this 2 equals 0. You have to find the path of variable point P. What is the requirement? The requirement is from the point P, the distance say D1 to S1. The distance is D1 to S1 and distance is D2 to S2. The requirement is the point P should travel at an equal distance to both the circles. In other words, V1 should be equal to V2. Under that condition, what is the path of P? Right? V1 equals V2 at equal distance to the two circles, S1 and S2. Right? You understand it now? Any other question? Anything you want to discuss from the book exercise, textbook exercise? Question number 15, the same page. Can you do asking? Mark 15 the key. I'm sorry. It's 15. You want 19. Did I give you up to 9? Last day up to 19. I'm sorry. I mean, you could do up to 18. Now today you can do 19. It's a very simple question. 19 days only today that we discussed is asked to find code of context. Sorry, mama kille 19 it has to be up to 18th last day. Now you can do from 19th also. Okay, number 19 is code of context. Now you know how to find it. Any other question? Right. Sorry, mata වැරදිලා මම කියන්නේ up to 19. It has to be up to 18. මම කල්පනා කරන්නේ අපිට අලුත් theorem එක කරන්න වෙලා තියෙද කියලා. The next theorem is S plus lambda L equals 0. මම හිතන්නේ ඒක පටන් ගත්තොත් කරන්න කියලාද කියන්නේ. හරි ඊළඟ theorem එකට යන්න එහෙනම්. It's not like a single theorem. It's one of like a family of theorems. There are some similar theorems you find in the algebraic geometry. This time you are given a circle, the theorem. You are given a circle is equal to 0 and a straight line. I'll draw it the other side. This is a circle is equal to 0 and a straight line L equals 0, right? The straight line intersects the circle. You are given a straight line and circle which intersect, right? Say these P and Q are the points of intersection. P and Q are the points of intersection. You are asked to find the equation of any circle. So the thing is, how many circles can we draw through these common points. You are given a straight line, an intersecting straight line, and a circle. How many more circles can we do through these two intersecting points, common points? How many circles can we do? How many circles can we do through these 2 points, common points, P and Q? Yeah, infinite number. Yes. Yeah, Rani says, let me say it's infinite number. Yes, correct. You can draw infinite number of other circles through these 2 points P and Q. The theorem says all any of such circles, passing these two common points can be written in the form S plus lambda L equals 0. S plus lambda L equals 0. This should remind you something somewhat similar, right? In straight line we did once you are given two intersecting straight lines, L1 equals 0 and L2 equals 0. Any straight line that passes this point of intersection can be written in the form L1 plus lambda L2 equals 0. Any straight line that passes the common point can be written in the form L1 plus lambda L2 equals 0. Isn't it an extension of the same theorem? This time you are given a circle and a straight line intersecting circle and a straight line. Any circle that passes the common points can be written in the form x plus lambda L equals 0. So later on in the same section circle, you will see another theorem. Given two straight circles, x1 equals 0 and x2 equals 0, right? So two intersecting circles, any circle that passes the two common points, 2 points of intersection, can be written in the form x1 plus lambda s2 equals 0. Another form of the same version of the same theorem, right? The first that we have seen here, like another version of that, you will see another one later on, right? So it's like one of a family of similar theorems. So we say the theorem is the equation of any circle that passes the common points of the intersecting circle x equals 0 and the straight line L equals 0. L equals 0, yeah, can be written in the form. Any such circle can be written in the form S plus lambda L equals 0. S plus lambda L equals 0, right? So you need a particular circle passing these two common points. So you will have find corresponding lambda value upon whatever the data, right? will be given some data. Upon that, you can find the value of lambda, or if you want some specific circle. Proof එක අපි අනිත් දවසට තියාගමු ළමයි. දැන් theorem එක ලියා ගන්න. theorem එක ලියා ගන්න. අපි මේ example එකක් දැක්කම. Proof later. විභාගයේ proof එක આવොත් මේක ලියන්න එපා. අපි ලියන්නේ මොකද්ද කියලා ඊළඟ දවසේ ඉගෙන ගනිමු. How many days we need to circle? The theory parts we can cover in 2 more lessons. Most probably, yeah, in 2 more lessons. ඊපස්සේ ඔයගොල්ලන්ට තනියම පුළුවන් නේ past papers ගණන් ඒවා හදන්න. In about 2 more lessons අපි දැන් පැය දෙකයි කාලක් වගේ කරන්නේ. Yeah, next day we start like a new set of theorems. This is the last of the sequence of theorems that we have been doing. Circles ඉවරුනාම එතකොට අපි trigonometry කවදාවත් දෙකකින් මේක ඉවර කරන්න පුළුවන්. ඒත් අපි trig ඉවර කරලා තින්නේ, calculus ඉවර කරලා තින්නේ. මේකෙන් algebraic geometry ඉවර කරනවා. අපිට ඉතුරු වෙන්නේ ඒක හොඳයි මේ ඔයගොල්ලෝ අපිට ඉතුරු වෙන්නේ some lessons in algebra only, right? For pure maths. algebra වල ලේසි පාඩම් ටිකක් ඉතුරු ළමයි. මොනවද ලොකු පාඩම් එකයි තියෙන්නේ complex numbers. මම කොහොමද ඔයගොල්ලන්ට වැඩිපුර වෙනම concept දාලා ඒක කරන්නේ ඉතියේ. Complex numbers අනිත් ඒවා කොහොම ලේසි පාඩම් මොනවාද induction එක දවසෙන් පුළුවන් series more in 1 or 2 days lessons you can finish it. Induction series ඊට පස්සේ binomial theorem 2 lessons enough. Then permutation and combinations එකටත් දවස් දෙකක් ඇති. Matrices දවස් දෙකක් ඇති. right? පොඩි පාඩම් ඉතුරු ලොකු වැඩ අපි ඔක්කොම ඉවර කරලා තියෙන එක ලොකු පාඩමක් තියෙන්නේ මේ complex numbers ඒක කොහොමද වෙනම කරන්නාම බලාපොරොත්තු වෙන්නේ. applied maths වලත් අපි බර හරිය ඉවර කරගෙන යන්නේ. ඔයගොල්ලෝ කලබල වෙන්න එපා. මම අනිත් කාරණේ මේ මම ඔයගොල්ලන්ට revision papers වැඩේ පොඩ්ඩක් නැහැනේ හිටියනේ මම මේ revision papers මම අද හිත වෙනකොට දාන්නම් තමයි ඔයගොල්ලන්ට WhatsApp කරොත් ප්‍රශ්නයක් වෙන එක නැහැ නේද? WhatsApp link එවන්නම් papers revision papers ඔයගොල්ලෝ කරන්න answer sheets උත් මම ඒ විදිහට දාන්න බලන්නම්. ඊට වඩා හොඳ විකල්පයක් තියෙනවා නම් මම කියන්නම්. හරි සමහර මේ ඔයගොල්ලෝ ඉන්න YouTube link එකට මට දාන්න පුළුවන් වෙයි. ඒක වඩා හොඳයි WhatsApp කළොත් 2021 22 ළමයි ඉන්නවා. ඒ ළමයිනුත් කොහොමද බලලා කරන්න කියලා. ඒගොල්ලෝ හොල්මන් වෙයි. එන්න ඊට වඩා හොඳ විකල්පයක් විදිහට මම මේ channel එකටම දාන්න බලන්නම් මොනවද answers and revision papers. මේ සතිය නම් බලන්න ඔයගොල්ලෝ නැවතුන තැනින්. හරි? දැන් මේක ලියා ගන්න. Google Classroom. හරි මම බලන්නම්. ඒකට දාන්න හරි. ඔව් දැන් එකම ප්‍රශ්නේ දැන් 2020 ළමයින්ට දාන එක 21 22 ළමයින්ට මේ යන්න තියනවා හොඳ නැහැ. මේ ළමයි මේ කර්පුරාසල මේ කලන්ත දාලා වැටේ ඕගොල්ලෝ දාන පේපර් එකක් වැරදිලා මේ අරගෙන කරන්න කිව්වා. මේ ප්‍රශ්නේ බේර ගන්නත් උසයි. I find some solution and let you know, right? About revision papers. මම එකක් දෙයක් කම්ප්ලේන් නැති කරලා තියෙනවා ඔයගොල්ලන්ට. මේ just එක හැදලා ඒව දාන්න. I think vectors. The last revision paper I gave vectors, and I have prepared the systems of forces. Vectors එක හම්බෙච්ච නැති අය ඉන්නවනේ. කරපු හම්බෙච්ච නැති නෙමෙයි. කරපු නැති අය. මම ඒක දාන්නම් ඉස්සෙල්ලා. Then answers for that. After that, the other paper for systems of forces. එහෙම කරගෙන යන්න ළමයි ඔයගොල්ලෝ කිසිම ගැටලුවක් තියාගන්න එපා, කිසිම සැකයක් බයක් තියාගන්න එපා. අපි අවශ්‍ය වැඩ ටික කරනවා. ඔයගොල්ලෝ ගෙවල් වල දෙමව්පියන් කලබල කරන්නත් එපා. මම කලින් කියලා ඇති. මේ මොනවද රිවිෂන් පේපර්ස් ඉවේ පේපර් ක්ලාස් රිවිෂන් ක්ලාස් කීකේ ගුරුවරු දානවා. දැන් මේ දවස්වල නම් නැහැ හිතන ඇත්තේ වැඩි හරියට. මේ එහෙම දාන්න උවමනාවක් you need answers for functions. මම ඒ ටික ඔක්කොම answers දාන්න බලන්න. හරි. මම ඒකට විකල්පයක් කරලා දාන්නම්. ඔයගොල්ලෝ මේ කලබල වෙන්න එපා. මම ඔයගොල්ලන්ට අවශ්‍ය වැඩ ටික ඔක්කොම කරනවා. විභාගයට සූදානම් කරන වැඩ ටික. මේ දැන් අලුතෙන් පොඩ්ඩක් වෙනස් කන්ටියක් කරන්න මේ තියෙන තත්ත්වයටදී කොහොම වුණත් අවශ්‍ය වැඩ ටික කෙරේ. ඔයගොල්ලෝ කලබල වෙලා දෙමව්පියන්වත් කලබල කරලා කලබල වුණොත් වෙන්නේ ඒකට විසඳුම් ගන්න ගියාම වෙන තවත් කලබල ඇති වෙන එක. හරි. මම ඔයගොල්ලන්ට කියලා ඇති. මොකක්ද අර මේ කසන වෙලේ ආවොත් හිතෙන කසන්න තමයි. කසනකොට මොකද වෙන්නේ? වෙලේ හොඳ වෙන්නේ නැහැ. තව වැඩි වෙනවා. තව වැඩි වෙනකොට තව කසනවා. ඒක තව වැඩි වෙනවා. ඒ වගේ දැන් ඔයගොල්ලෝ බය වෙලා කලබල වෙලා ඉඳාගෙට මේ දෙමව්පියන්වත් කලබල කරන් ගියාම ඒගොල්ලෝ යම් පියවර ගන්නවා. ඒ මේ ළමයා ගැන හිතලා එතකොට වෙන්නේ තවත් කලබල වෙනවා. Right? Doubts with the vectors answers. Vectors answers. කෝල් එකක් දීලා අහන්න කියන්නේ නැත්නම් මම ඉස්සෙල්ලා බලන්නම් මම දාපු උත්තර වල වැරද්දක් තියෙනවද කියලා. මම ඔයගොල්ලන්ට උත්තර දුන්නාද? Answers for vectors too. Vectors revision paper. Did I give answers? What is it? Did I give answers for vectors one? Yes. I'll check them if there is any problem with the answers. Right? ඔයගොල්ලෝ කියන්නේ මගේ ආන්සර්ස් වල මොන හරි සැකයක් තියෙනවද කියලා ඔයගොල්ලෝ තේරුන්නේ නැහැ කියලා. මගේ ආන්සර්ස් වල වැරද්දක් තියෙනවා. මම බලන්න. What are the numbers? You have any idea? Or parts? මම දීපු උත්තර වල මොන හරි මිස්ටේක් එකක් තියෙනවා නම් මට කියන්න මම බලන්න. මම ඔය ඔක්කොම ආන්සර්ස් දාන්න බලන්න. අඩුපාඩුවක් තියෙනවා නම් හදලා ගන්න. Right. මට දැනුම් දෙන්නකො මොනවද තියෙන ප්‍රශ්න කියලා මම මොනවද කරන්නේ. Right. මම හිතන්නේ මේකට මේ examples කරන් ඉඳ තියාගන්න අපි අනිත් දවසේ කරමු proof and examples. Until then you can go to the for homework you can go to the same exercise and do up to questions 2, 3 and 4. Yes, many. Two, 3 and 4. I'll check them, right? I'll take my answers and let you know if I find anything. If you need any correction, I'll do them. Do so and let you know. For the moment, for this week, you can from the same exercise, you can try up to up to 22, up to and including 22, up to and including 22. You try them from the same exercise in page 190. Exercise page 190. Do up to 22. Right? Make a proof එකක් කරලා examples අනිත් දවසේ කරමු. මේක ඉඳ තියාගන්න ළමයා. proof එකයි examples වලයි පිටු දෙකක් විතර ඉඳ තියාගන්න before you are doing homework. Do about 2 pages. එහෙමනම් අපි ඊළඟ සතියේ මේ පාඩම කරමු. හෙට අඟහරුවාදා 10 මාර්ච් applied maths පාඩම කරමු. නම් හෙට හම්බ වෙනකම් ඔයගොල්ලෝ හැමෝටම අයිබෝවන් උත්සාහයි කාටත් nirogi surya prarthana prabhu.